Hello everyone, welcome to the webinar today. My name is Raymond Lawrence, and yes, we're going to be talking about how you can increase your application performance with SQL auto caching and no code changes. So an executive summary, who is this for? This is for anyone with data in a database that wants to improve cost and performance. So that's pretty much almost everybody. All our applications are based on a database, and the database tier could be one of the most expensive parts of your overall application architecture. What are we talking about? We're talking about how to quickly leverage Hazelcast in existing database applications to improve both speed and scale. And why? Well, we know that Hazelcast caching speeds up data access for applications, and we can use it to reduce database load and cost. So if there's a way that we could use it for more applications, that's beneficial. Now I want to be clear from the start, this applies to Hazelcast open source and commercial. It doesn't matter what version you're using. So as an overview, I am the Vice President of Engineering from Heimdall Data. I'm a very active Java developer. I've developed numerous JDBC drivers, including a JDBC driver for MongoDB. I'm a tenured professor of computer science at the University of British Columbia, where my specialty is database integration and performance. And I've worked as a database consultant for companies small and very large, including working for over a year with General Electric on their big data industrial internet initiative. So if we take a look at data storage trends, the one main trend that should be clear is there's no one size fits all system. If you were going to build an application 10 or 15 years ago and had to pick a database, your choices were rather limited. You had various relational database technologies, either open source like MySQL or Postgres, or commercial databases like SQL Server or Oracle. Now, what we've seen is with the vast variety of applications for databases, we've seen a lot of specialized systems who have better performance or better cost performance in these areas than a generic solution. So transactional systems are still very well served by relational databases, but there's been a growing trend to have in-memory systems for those. If you have a lot of data, so you're doing big data analysis, data warehousing, the types of systems you'll use and the way you architect them will be different. You may use column stores or grid-based solutions or Hadoop or a variety of other technologies in those domains. NoSQL systems were designed to be highly scalable and highly available, which wasn't the original design choices made with relational databases. And there's been the ongoing trend to put things in-memory databases, in-memory data grids, because we know we get better performance out of that. Rather than have the data on secondary storage, if we can have it in memory, we can return it to the application faster. The other thing I want you to realize is although usage of in-memory grids such as Hazelcast is increasing, the majority of the data still resides in other data management systems, whether it's traditional relational databases or a variety of other things. Most of our data is not in in-memory grids at this point. So if we look at the traditional, I'll say, database application architecture, you have your database, whether it's an open source, Postgres, MySQL, a commercial, Oracle, or SQL Server. And it doesn't matter if it's on-premise or cloud. We could be talking about Amazon RDS here as well. Your application will consist of the application code and a database API, which is basically allows your application to talk to protocol over the network to talk to the database and get results back. So each vendor provides an API for accessing the database over the network for particular languages that application developers write in. They often also will follow standards such as JDBC and ODBC, which hopefully make changing between databases a little bit more portable. Now let's say you wanted to add Hazelcast to an existing database architecture like this. So you still have your database and your application accessing the database for some of the data it needs. Then what you would add to this is the Hazelcast API to allow you to talk to the Hazelcast in-memory data grid, plus some application code. So for instance, where before your application might have went to the database for a particular data item, you might have seen that you can get better performance if you put that data item in Hazelcast. But now what you would have needed to do is go change that application, write some code. So now whenever that application went to access that data item, it went to a Hazelcast first before it went to the database or something like that. Now there may be some synchronization between the data grid and the database, but typically that's isolated from the application. The key thing from the application point of view is now you have two data access code paths that you have to code, that you have to maintain, and you have to make decisions on how you want to support and use them. So our motivation in this presentation is, can we access more data using Hazelcast in memory data grid rather than going to the database? And how easy can we make that? Why do we want to do it? Well, clearly we could often get better performance. We can get faster retrieval from Hazelcast rather than the database. Another quite significant benefit we can get is cost. Now, depending on what your database tier consists of, it could be commercial systems, which have very high database license and server costs. So anything that you can reduce the load on those databases will save you money in terms of licensing, in terms of not requiring more hardware or cloud resources for that data tier. It also will give you the ability to scale. So now you can handle larger query loads, maybe traffic spikes, changing access patterns. You may not have to scale your database to the maximum possible query load if you can have some of that traffic handled by Hazelcast at a more reasonable price point. And you're also adding some resilience to your architecture. Now you're a little bit more fault tolerant and you have some redundancy. Your application can get some of its data from Hazelcast rather than database, which may allow it to respond better if there's issues with your database server in your architecture. So the goal, can we get to use Hazelcast easily for existing applications without requiring code changes? Now you've got a couple challenges here. If you have an existing application, it has a data architecture that is built, and it's often very hard to change. And it may not be easy to leverage new technology depending on how this application was designed. So what Heimdall is a protocol-based data access layer that allows any application to use Hazelcast without changing code. So it's at the protocol level between how the application talks to the database. It's implemented as a proxy that dynamically and transparently caches into Hazelcast. So let's take a look with a diagram on how introducing Heimdall into the architecture changes things. So we still have our database in our application in our vendor database API that was communicating with the database. But now what we have in between is the Heimdall proxy. So instead of the application communicating directly through the database protocol, it communicates through the Heimdall proxy. Now I'm showing the Heimdall proxy on the application server itself. That's one installation path. It also could be on a separate server as well, depending on how you want to do the architecture. The Heimdall proxy is configured by a central configuration server. What this allows you to do is enter configuration information in one place and have it automatically distributed to as many application servers as you have. So eliminating a lot of these configuration nightmares you have when you try to make changes within your application. So how it works, your application will execute a query, an SQL query like it was before, but instead of that going directly to the vendor database API, it goes through the Heimdall proxy, which will often send it to the database API, goes to the database, and then the results will come back. Now this looks very similar, except now we have the proxy in between. But what this is allowing Heimdall to do is collect statistics and information about the database traffic that's going from the application to the database. And all those statistics are available in that configuration server, which you can use and analyze and come up with design choices on maybe things that you want to cache. Once you decide what you want to cache, it's as simple as writing some rules to say, if I see queries that look like this pattern, then I want you to cache them. And so what you can do then is you can put results of those queries that have been cached in a local cache directly in the application server and also in Hazelcast to share across application servers. So now what this allows you to do is get in-memory performance with executing queries and not having to send them all to the database. The Heimdall configuration server will also be aware of failover events in a database. So if you have multiple servers, primary, secondary, it will be aware of that and inform the Heimdall proxy on how to intelligently route queries through failures. So let's drill down into some of the details here. The database is supported at the protocol level. Remember, protocols are database specific. MySQL and MariaDB is supported. PostgreSQL is supported, and SQL Server is supported. There's also a JDBC driver implementation, which allows any database accessible with JDBC to use this technology. So that would include Oracle, IBM DB2, any other product. And it doesn't matter where the database is deployed. It could be on-premise, it could be cloud, it could be some hybrid of the two. In terms of what the application language supported, if you're using the JDBC driver version, any Java virtual machine based language, typically Java, but anything based on JVM would be supported. For the protocol proxy, any language is supported. So PHP, Python, Perl, whatever you want. Since it's happening at the protocol level for the database, it doesn't matter the language that the application is written in. So are there really no code changes? And the answer is yes. The only changes that would require to use this application is you've got to deploy the jar, which the Heimdall code is written in, and make a URL change to access the database. So this is just really a configuration level change that you're making. So before, where you might have at the proxy had MySQL and specified the server URL and database on where the server was residing, now you'll say MySQL and then provide the proxy server URL and the database. If you're using JDBC, where before you would say JDBC, MySQL, and then provide the server information, now you'll say JDBC Heimdall and provide the information for the configuration server, where it can provide the locations of the data sources that will be connected to. That's it. That's all the changes you have to make to get started. It's that easy. So once again, a review of how this works. The Heimdall proxy is intercepting the database traffic that's coming between the app and the database. It has rules internal to it to manage traffic flow, which include caching data to Hazelcast. Now these rules we'll talk about in a little bit can either be managed automatically by Heimdall or configured very fine-grained level by the user. So you have a choice on the level of control and precision that you want with caching and how you're routing your queries. When the application performs a query, the first request goes to the database. If it is something that has been flagged to be cached, it will be cached at the app server and in Hazelcast, which we refer to level 1 and level 2 caching. And then future requests will be served from the cache rather than going to the database. So we know that caching can improve performance. But one of the first questions you have, or first two questions you have is, should I cache? And if I should, what should I cache? And those are really hard questions to answer. Determining which queries and which data to cache is not an easy problem. How Heimdall does it is it uses real-time analysis and statistics to determine the answer to these questions. Should I be caching? And what should I be caching? Information that Heimdall collects are the query cost and the frequency, the query responses and how much they are changing and their variability, and even the relative performance between Hazelcast and the database. So even though something might not be frequently changing, maybe it's still faster to get it from the database rather than Hazelcast. So it collects all these statistics and provides recommendations on what is cacheable. As part of that, it's going to detect what's transactional and rapidly changing data and just not cache it because it knows that you're not going to get a benefit from it. So what you're going to get are cache recommendations and potential benefits that you can perform actions on at a very fine-grained level if you want to. I want to cache this particular query only, or this particular table or data set. It also has the feature of auto-caching, where the default is anything's available to cache, and using this real-time analysis, it'll figure out what is valuable to cache, which won't be everything. It's only what is going to be useful and give better performance. So here's an example of a screenshot with the Heimdall configuration server and all the statistics it's gathered. The queries you see are SQL generated by a web-based application. And this web-based application has really heavy read traffic. And it's one of the sweet spots for basically caching. If you have a web-based application, they're typically very read heavy. These top few queries are taking about 700 microseconds per query, which isn't too long in the grand scheme of things, but they're executing thousands of times, and it's very repetitive, the answers that are getting back. So really low-hanging fruit for caching. And it turns out these are the top 3 most expensive queries for the application that it's executing. So what you can do then is once you've identified these queries and say, yes, I want to cache them, what that will do is generate a regular expression. So queries that look like that format will be flagged to be cached. When the results are coming in, they will be put in the level 1 and level 2 cache, and then they'll be served from the cache rather than served from the database. So here's a screenshot of what that would look like in terms of the caching rules. Those 3 queries have been turned into 3 caching rules. And when the Heimdall proxy sees those queries that match those rules, they'll be cached. So if we take a look at a before and after scenario here, before we identified these queries and did the caching, remember it was about 700 microseconds per query, significant load. They were the top 3 most expensive queries from the application's point of view. Once we enable caching into Hazelcast, now that they are the 20th and 21st most expensive queries from the application's point of view, your response time is 70 microseconds rather than 700. So from the application's point of view, you've sped up your database access by 10 times. And as an added benefit, you've significantly reduced the number of queries that went to your database, which either could allow you to scale your database differently for more users or less resources. So here is screenshots of what the dashboard will be, which is showing real-time statistics as it went along. So what you're seeing right at this point here where it says cache on is the caching was turned on while the application was running. So initially the application was doing about 500 queries per second, and you can see that in the blue line for the overall queries. The black line is the number of queries that are going to the database, and the green line is the number of queries that are being served by the cache. You can see as soon as the caching is turned on, the number of queries served by the database has dropped dramatically. We're now about maybe 100 queries per second versus about 500. And correspondingly, the number of queries served by the cache has went up significantly. The other key thing to notice out of that is we've went from serving about 500 queries per second to about 800. So just by introducing the caching for Hazelcast into this application, we can have more users or support more concurrent requests. The bottom graph is showing how long the application sees for its queries to be executed. So the black line is the database, the blue line is the overall time, and the green line is the cache time. So it takes about, on average, 700 microseconds for the database to respond to queries over the entire query load. When turning caching on, we see that the database is still serving about queries about 700 microseconds in time, but the overall time has decreased significantly because on average, we're serving a lot of queries from cache, which is reducing what the application sees is the time for it to have queries. We're down to about 100 microseconds, so about 7 times improvement from the application's perspective on how long the queries are taking. So that's the benefits. We do have to talk about the challenges. One of the key challenges whenever you're caching anything is to make sure that the data you're returning from the cache is consistent or at least meets the consistency requirements that the application has. And so how you deal with that is invalidation and synchronization. Invalidation is the process of removing cache entries or at least not using cache entries when you know they contain stale data or data that's not consistent enough for the application requirements. And it's a fundamental challenge in any caching solution. And I hope you can appreciate it's more difficult in this situation as the application is not aware of caching. If you were using Hazelcast directly and writing the code, you would know when your data is going to be invalid, or you'll know how long the data would be good for because you're explicitly writing that information into your application. So what Heimdall does is it needs to keep track of the cache entries that it has. And first of all, remember these caching is at the SQL query result level. So you executed a query. What is being cached is the entire result that came back from that query. As part of that cache entry, we keep track of the query that generated it and the list of all the tables that were required to build that query result. And then what Heimdall will do is it'll automatically invalidate cache entries when it sees SQL statements, such as SQL DDL, or more commonly insert updates or deletes, that are using any of those tables. So let's use an example. If you have a query that you are caching, which is taking two tables, joining them together with some filter on it, the cache entry will contain the result set of that query and the query itself and all the tables that were used, in this case, table 1 and table 2. Now, if any application executes a command like update table 1, that's going to change a data value, which potentially could invalidate the consistency of that cached entry, then immediately Heimdall is going to invalidate that cache entry even before that update is getting executed on the database. The other challenge is, well, what happens if I have an application that is using Heimdall, but I also have other applications that are accessing the database that are not? So then in that case, Heimdall wouldn't be aware of any modifications that the database has been performed on it. And you really got two choices here. What we recommend as a choice is a REST API that allows you to clear the cache or invalidate entries at any time. So for instance, let's say you're doing a bulk load into your database and you know that this certain table you have now shouldn't be cached anymore because you've loaded new data into it, and so those entries should be invalidated. With a simple REST API call, you can tell a configuration server, hey, this cache data should be invalidated, and that'll automatically get pushed out to all the application servers. The other option, which database administrators don't like quite as much, is have some sort of active method inside the database. We've done approaches using database triggers, some more active methods using polling. Not as ideal because it's changing the database a little bit, but allows you some more fine-grained control on doing some invalidations. So just an example on what that invalidation would look like. Here's our architecture again. Remember, any invalidations that go through Heimdall, any inserts, updates, and deletes, Heimdall can know when to invalidate automatically. But if you had an application that was connecting directly to the database with SQL, there's no way Heimdall or any other caching solution would know that data entries have changed unless you had a way to inform it at the database level. So the easiest way of doing that is when you make that change, you make a web request on our REST API to the configuration server saying the whole database, certain tables, whatever granularity you want has been changed. So those cache entries, if they exist, should be invalidated. And that gets automatically picked up by all the proxy servers, all the application servers. So there's only one point of communication to do the invalidation. And then those changes would be made at the application level and at the Hazelcast data grid level. So once again, the benefits, you have the chance to do performance optimization of any existing database application. And you get the choice or to be able to understand if you should cache and any potential performance benefit. And you can deploy this immediately with no additional hardware or software. When you are caching, you're taking advantage of Hazelcast data grids in-memory, in-process performance. So that's going to give you a significant speed up with the added benefit that you can reduce your load on the database. And often for many customers, that's the bigger one because the database costs are significant, and anything to reduce that and make that more economical for cost performance is of a significant benefit. Now I've talked about Heimdall as a caching solution, but Heimdall is actually much more than that. It's an intelligent SQL query router. So we've already seen how queries may be cached and retrieved from the cache using Hazelcast, but there's other rules that can be applied that are often useful. One of the rules is a transformation. So an SQL query could come in and the proxy can dynamically transform that to a different SQL statement. So why would you do that? Often in data migration scenarios, there might be changes happening in the database that can't easily be reflected in the application. Or maybe the DBA can recognize some queries that are really expensive to execute at the database level, but you can't change the application. This basically gives you the ability to rewrite a query in between when the application sent it to the database. And there's a variety of ways that could be beneficial to you, and you didn't have to make changes to either side, the application or the database. Another key benefit is you can do query routing. So maybe your database tier has many different servers and you want to do load balancing or distribution, read-write splits, read-only servers, and your application is not aware of that, but you would like to be able the application to take advantage of that. So what this allows you to do is do load balancing and query routing where you should do it, where the communication between the application and the database. So that allows you to very easily do read-only servers, for instance, or to do read-write split without making changes at the app level. Another very common use case is when you want to execute queries asynchronously. And the most common use case for this is applications that do logging. So they want to keep track of information about a user or how people are interacting with the application. And this is used for statistics. But you really don't care if that's executed synchronously because it's really for background information later. But often the application will still have to wait for the database to insert those log records before it can continue processing. Heimdall allows you to do that asynchronously. So the application can keep going and then the log records can be inserted in the background. The other key feature is it allows for failover and high availability. So Heimdall is aware of the different database servers that you have. So if one database server goes down, what the application was using to connect to, Heimdall will automatically at the connection level switch to a backup server while the primary one isn't available. So this is just a screenshot of an example of some more of these rules. The first one is the asynchronous execute. This application is doing some logging. That doesn't need to slow down the application synchronously, so that can be done asynchronously. Here's an example of the forwarding, where this particular query, it was retrieving information originally from a relational database, but for a variety of reasons, in this case, they wanted to retrieve that information from MongoDB. So it didn't even have to be a relational source where that information is retrieved from. And in the last case, what we have is a query that was retrieving the entire customer list, which may have been an okay idea at the time when the application was first deployed, but not needed as the company grew and that customer list got larger. So we could transform that query before it hit the database to do a limit, so it's only returning the first 10 rows rather than the entire customer list. So as a customer case study, as an example on how you can apply a Heimdall is movietimes.com. They are a global online ticketing website with over 1.5 million users, and their entire architecture is deployed on Amazon Web Services. Now, the challenge they have is a surge in traffic, which is a good challenge that many companies are facing. Your web property, your application, you don't know how to scale it, and if it's being successful, you have this scale up problem. So they're having surge in traffic that's overloading the database, and it was too costly and takes too much time to develop a caching solution with their web property right now as it's running. So why Heimdall Data was interesting is you can do a diagnosis and cure of the SQL bottlenecks. So what is taking time in the application and how much is the database being used and can that be improved? And what they wanted is to be able to intelligently cache to Amazon Web Services to reduce the load on their database tier. That was their goal. So in one day, deployed Heimdall and Hazelcast. So now we could do caching of this existing application. The benefits they saw was a 10-time increase in database scalability because they were serving much of their traffic from Hazelcast in the cache rather than from the database. Now this also had the added benefit that anything like query spikes in traffic would be much more seamlessly handled by Hazelcast rather than the database. And it also saves significant developer resources. Remember, they could have tried to develop their own caching system and use Hazelcast directly, but that would have took time and money. And so they could save a significant amount of money by deploying Heimdall and Hazelcast together in their existing application. So I have a quick video here, which I'm going to narrate above to show you this working in practice, to get an idea on how it works. So what we see here is the Heimdall configuration server, and we're going to use it in the MySQL proxy mode. The data source is on RDS. It's an Amazon MySQL database. And if we go to the dashboard, what we see is the real-time performance of this application. Right now, there's no caching happening. We're doing about 500 queries per second, and the average query time is 700 microseconds. So that's our application. We're monitoring its performance right now with Heimdall, but we haven't done any caching. We can do an analysis to do on the per query level to see what's expensive in terms of queries. And here's these top 3 queries again that are very repetitive, executed thousands of times. And even though each individual one is not expensive, it'd be good to cache them. To cache at the individual query level, it's as simple as clicking a button and saying cache. And so what's being generated here are regular expression rules to say, if you see this query, I want you to cache it. And so instead of going to the database, you can go to Hazelcast. So those rules have just been committed. Application hasn't been restarted or anything. In real time, we can see the change that happened. Where before we were doing all the queries from the database, now we have about a 40% cache hit rate. Our queries per second have actually went up because we're serving some from cache. And from the application's perspective, our average query time has reduced to about 500 microseconds versus 700. That's just by identifying the top 3 or 4 queries that are cacheable here. Now, if we do an analysis again, after caching, we see those queries that we identified before, which were expensive from the application's point of view, have went way down in terms of what the application thinks they cost. They've went down to 70 microseconds from 700. So a significant difference from the application's point of view. That's fine-grained caching. If you want to just have Heimdall do it all for you in auto cache mode, you just have to set one rule saying cache as appropriate and let Heimdall figure it out. I just enabled that now, and you can see a dramatic difference from what we had before. We went from about a 40% cache hit rate to about an 80% cache hit rate. Not everything's cacheable. It figures out what the benefit is. But you can see we've even did a more dramatic decrease in the query time from the application perspective, down to about 150 microseconds on average. So that application would be seeing a significant performance difference, as with the database, because now there's a significant amount of queries that are not going there anymore. So our database load has reduced quite substantially. So hopefully this gave you an idea on how you could use Heimdall and Hazelcast together in an existing application. The analytic features are very easy to use. So even if you're not sure, is caching for me? I don't know if I have much that I could cache. What you could do is download Heimdall, put it in there in a few hours, and see what is cacheable and what is not. Maybe the answer is no, there's not too much that you can get a benefit from caching. Maybe the answer is, well, there's only a few queries that are beneficial. We've had several customers who just identified some of their biggest bottlenecks, and then they went and changed them, either manually or used Hazelcast directly. But often the case is there's quite a few queries that you might see a performance benefit in, and you can do it easily without changing your application with Heimdall. So next steps, there's a free download, 30-day trial to try out Heimdall, see if the analytic and caching features will be useful for you. And I thank you for your time, and I'm happy to take any questions that you have.
Great, thanks, Raymond. This is Ben Sawyer, the webinar host. We've got a Q&A box up in the upper bar of your WebEx Event Center. If you want to go in and submit any questions now, that would be great. If you're in full screen, you'll find it at the top of your screen on the WebEx tab, and if you're not in full screen, it'll just be in the upper right-hand corner of your WebEx interface. So I've got a question from Alexander. His first question is, he said I cannot find the Heimdall repository under Hazelcast GitHub account. Is Heimdall part of the Hazelcast project?
Heimdall is not currently a part of the Hazelcast project. It's basically a separate component, so you won't see it as part of the GitHub for Hazelcast at this time.
And another question also from Alexander. Do the Heimdall cache synchronize between the application server nodes, e.g. between
Yeah,
two nodes?
yeah, so that's a great question on synchronization. Really how it works is, I said there was two levels of cache, level 1 and level 2. So a level 1 is inside the application server itself. So that's not synchronized between application servers. But obviously Hazelcast nodes, the level 2 would be synchronized between application servers because the data is put in Hazelcast and retrieved from the individual application servers. So depending on how you want to use the caching, either yes, it is if you're putting the data in Hazelcast, or no, it's not if you're just putting it in the application server. And you get control of which ones you want to do.
Okay, Raymond, if you don't have any more questions over there, let's go ahead and wrap up.
Okay. Well, thank you very much for attending the webinar.
All right, thank you. Everyone, have a great day.